Hello, I'm Mallory Newson, and I'll be doing a conceptual video on working a problem out. I decided to do the work energy theorem and kinetic energy from section 6.2, and I decided to use question 13, and it states that a fighter jet is launched from an aircraft carrier with the aid of its own engine and a steam-powered catapult. The thrust of its engines is 2.3 times 10th raised to the 5th power n. And being launched from the rest, it moves through a distance of 87 meters and has a kinetic energy of 4.5 times 10 to the 7th power joules at liftoff. What is the work done on the jet by the catapult? And I'm sorry for the angle. It's just hard that I couldn't place it in a way to make it work. So the initial velocity is 0. And we are given the distance, which is 87 meters. We are also given the thrust of the engines, which is 2.3 times 10 to the 5th power n, and the kinetic energy, which is 4.5 times 10 to the 7th power joules. Yes, that all that was given. And we can find the answer by using the work energy theorem, which is W engine plus W catapult equals a half times M times V squared minus 1 times M times V squared to 0. Well, 0. And then we subtract W engine from the side with the catapult to the other side to get W catapult by itself. Equals 1/2 again times, not 1/2, no, not 1/2, a half times mv squared minus a half times m raised to the second and 0 minus W engine. We also use what was given right here and substitute the places in the problem using this formula, which is half mv squared minus a half mv to 0 minus F thrust times D, the distance. And we use what's given in this problem. So a half mv squared would be the kinetic energy, which is 4.5 times 10 to the 7th minus, and for this it is the half mv squared and 0, that would just be 0, and minus the F thrust times the distance, which is 2.3 times 10 to the 5th power times 87, and then let me get my calculator. Sorry, my pencil fell. To do this, we would just plug it in. We would get 4.5 times 7 minus 0 minus parentheses 2.3 times 10 to the 5th times 87, and we get that number. Equals 2499000. We would get that number, joules. But we can also simplify that by 7 decimal places to get equals 2.4 times 10th to the 7th joules, or it depends on what the teacher wants or what you want, and you can use the 9 right there to round it up to get 2.5 times 10 to the 7 joules as the answer.